Ever wondered how the big transport planes came to be? After many attempts of converting old bombers into transport aircraft, it became apparent that specialised planes needed to be built from the ground up. We explore the C-5 Galaxy. We then go back in time and check out a very bold plan that required a number of large bombers to take off from an aircraft carrier on a one-way trip. From the first flights, the US Navy took great interest in the Wright brothers' flying machines. We investigate the first joining of sea power and air power. In the race to supply the military with transport aircraft, it was the Lockheed Company that won. The four-jet C-141 Starlifter was a winner from day one. Due to the wing oscillation, the fuel tanks had to be an articulated design. The four huge jet engines had a reverse thrust of 40% to assist landing on short runways. In fact, the C-141 was the first jet transporter. The Starlifter's engines were capable of lifting much more weight than the plane could actually hold. This was addressed in later versions of the plane. The problem was resolved by stretching the aircraft's fuselage. During the 70s, the entire fleet of 270 aircraft were returned to Lockheed for modification. The planes were lengthened by 7.16 metres, which increased cargo capacity by about 1/3. As of today, the plane has been made in 30 different configurations. The first prototype flew on the 60th anniversary of the Wright brothers' first flight. This was December 17, 1963. The first C-141A was delivered for service in October 1964. The service life of the C-141 Starlifter fleet is coming to an end, and a gradual retirement phase-out was begun and was expected to be complete by 2006. However, some Starlifters are still in service today. Again, the Lockheed Company won a contract to build a bigger transport, and in 1970, the C-5 Galaxy was delivered. Lockheed kept all the best features of the Starlifter: the distinctive high T-tail, 25-degree wing sweep, and 4 turbofan engines mounted on the pylons beneath the wings. The C-5 is similar in appearance to its smaller sister, the C-141, but the C-5 is substantially larger. The massive wingspan and weight caused considerable wing oscillation. This challenged the designers and engineers of the day. The answer was a highly sophisticated computer-controlled damping system. As with any large wingspan, movement and flex is expected. However, the C-5 without the dampener is excessive. This shot is the C-5 flying with the damper disabled. Without aerial refueling, a C-5 can fly 2,600 nautical miles. With aerial refueling, the aircraft's range is limited only by a cruise endurance. The C-5 is one of the largest aircraft in the world. It can carry outsize and oversized cargo worldwide and can take off or land on relatively short runways. Like the Antonov, the landing gear can be knelt, so the cargo floor is at truck bed height to assist vehicle loading and unloading. Ground crews can load and offload the C-5 simultaneously. In fact, the full-width drive-on ramps allow for loading double rows of vehicles. The largest success of the plane is its ability to take off fully loaded within 2,500 metres and land within 1,500. A study confirmed the C-5 still had an airframe service life of 80%, so an aggressive program to modernise the C-5 was initiated. The program began in 1998 and included upgrading avionics, improving navigation and safety equipment, and installing a new autopilot system. Another part of the plan dealt with new engines, pylons and auxiliary power units. This modernisation program will ensure the C-5 will be used well into this century. The attack by American bombers on the heart of the Japanese Empire in April 1942, commonly known as the Doolittle Raid, probably stands out as one of the most strategically significant air attacks during all of World War II. December 7, 1941, Japan used their combined Pacific Fleet in the infamous Pearl Harbor attack. It consisted of 2 fast battleships, 6 aircraft carriers, 8 destroyers, 3 cruisers and submarine escorts, and a total of 360 aircraft. The attack was over in a little more than 3 hours, and by the end of the day, most of the US Pacific Fleet lay broken and burning. December to March brought even more significant advances by Japanese forces. The American generals began to realise that a bold stroke was needed to restore the morale of the public and of the fighting forces. The Japanese morale was soaring, and no one in Japan thought that the home islands would ever come under attack. But this is exactly what was about to happen. A very bold plan was hatched. The plan involved loading large bombers onto an aircraft carrier. It would be the first time such large planes would be launched from a carrier, and they would not be able to land back on the carrier due to their size. The US Army Air Corps brought in Lieutenant Colonel James H. Jimmy Doolittle to lead the project and train the crews. The 800-foot flight deck was to be crammed with 16 twin-engine bombers. Usually, the B-25 had a takeoff run of 1,400 feet. The Hornet would only allow the heavily overloaded bombers 500 feet. When the training had been completed and the Hornet left her west coast port for a rendezvous with the rest of the battle. Approximately 600 miles from Japan, instead of the planned 400, the Nito Maru made the first reported sighting of Admiral Halsey's task force and put the Japanese on alert. Halsey ordered the Mitchells to be launched at once, ultimately accepting over 200 extra miles for the bombers to fly. Doolittle's own bomber was the first to rumble down Hornet's pitching flight deck. Being the first plane meant he only had 467 feet of carrier to launch from. Between the speed of the carrier and the winds from stormy weather, he and the other pilots had the benefit of a 50-mile-per-hour headwind. Still, many of the planes nearly stalled on takeoff and seemed to hang over the high seas for an extended period, before finally gaining altitude. Immediately after the launch, Halsey hurried back to the safe waters, as the USA could not afford to lose such a carrier. Once in the air, the bombers separated, each with its own set of targets. Surprise was a critical element to the raid, and it worked. Only one bomber was prevented from reaching its target by Japanese fighters. A total of 4 cities had been attacked: Tokyo, Kobe, Nagoya and Yokosuka, and the bombers then headed off to the Chinese mainland. But the extra 200 miles meant the planes were low on fuel. One was forced to land in Russia and the crew were interned. Another 2 had the crew captured by Japanese soldiers in China. As Roosevelt had calculated, the daring raid was the boost American morale needed. The end result was many fighter aircraft and men were kept back on the Japanese mainland to guard against further attacks instead of being sent to islands in the Pacific. Their presence on those islands could have made the fight more difficult or even impossible for the Allied troops. In 1909, we were barely able to claim mastery of building petrol-driven four-wheel vehicles, or cars as they became known. Yet some forward thinkers were already adapting the internal combustion engine to powering aircraft. But it was the Wright brothers who brought this dream to reality. Although not the first into the air, they were the first to establish the principles of flight in the shape of wings. Over 100 years ago, on a windy sand dune on the North Carolina coast, two bicycle repairmen altered the course of human history. They took to the air in a flying machine. Wilbur and Orville Wright, after years of designing and tinkering with gliders, placed a small engine aboard their fabricated plane and made the first powered flight. It was December 17, 1903, and the Wright brothers made 4 flights that day. Orville was first at the controls. The plane slid along a starting rail and then ascended into the air. The first flight lasted only 12 seconds, and Orville covered a mere 120 feet. But it was the first true powered flight of any aircraft. The second flight, with Wilbur at the controls, went only a little further. On the 4th attempt of the day, Wilbur skimmed the sand. But then he made an abrupt manoeuvre with the elevator which caused the plane to pitch into the sand. A flight of 59 seconds and 852 feet was recorded. The Wright brothers were jubilant. But as they went off to their wooden shed to celebrate, a gust of wind caught the wing of their flyer and sent it end over end, finishing their attempt for the day. The Wright brothers were true inventors, true innovators, and true engineers. Methodical in their approach, they filled dozens of notebooks with mathematical calculations on the design of their flyer. It was the Wright brothers' painstaking process of trial and error that gave them the edge over competitors who were also vying for the skies. In the initial months after that first successful flight, Orville and Wilbur had a vague grasp of the scope of their achievements. They knew their invention was historic, but to a degree, even their vision was limited. However, one spectator of a flight of the Wright brothers saw an immediate need for a flying machine. During one of the Wright brothers' subsequent flights of their Kitty Hawk, a naval observer, Lieutenant George Sweet, commented that the Navy must have that. It will be most important to us. With these words, Sweet basically instigated the joining of air power and naval power. However, it wasn't until World War II that the practice of using planes off floating platforms was tested in combat conditions. But it was the aircraft that underwent major refinement to be useful at sea. The Navy's first attempts at air power concentrated on taking off and landing on water. In 1910, and again in Virginia, a civilian pilot named Eugene Healy tested the idea of taking off from a ship and landing on terra firma. He used a wooden ramp built over the bow of a cruiser as a runway for a 50-horsepowered Curtiss. He is successful, and 2 months later he attempts the reverse, taking off on land and touching down on a ship. During 1922, the battleship Jupiter was transformed into the USA's first aircraft carrier. It was renamed the USS Langley. Arresting wires were strung across the deck of the runway, and planes were fitted with hooks, which would snare the wires and bring the plane to a halt. Braking systems for planes had not been designed, and the pilots flew without the use of safety harnesses. The first of many problems became apparent. The undercarriages of the planes were simply not strong enough to cope with the rough landings. Pilots, not wishing to miss the wires and end up in the sea, slammed the planes down very roughly. The Hawke Company, who built most of the first planes, knew about the problems they would face in constructing a plane that would stand up to the rigours of carrier landings. Even though the planes of the day flew quite slowly and could glide well, they were lightly constructed, and now the designers were faced with strengthening the plane and adding weight. Strong and lightweight metals such as titanium or materials such as carbon fibre were not yet available. So strengthening came at a cost, and the cost was weight. However, some remedies were simple enough and made enough difference to prove that using planes from Langley was feasible. These included designing planes that gave pilots better visibility over the nose of the plane to give them better judgment while landing, and widening the track of the undercarriage to increase stability and better training procedures. The British were also developing sea takeoffs, and this was one idea, the laying down of a buoyant runway. It was not overly successful. The British returned to the more conventional aircraft carrier and faced the same problems as the Americans. Today, the Lockheed JSF is the shape of the modern carrier-based fighter plane. The Airbus 380 is the shape of today's civil aircraft. Yet both of these craft rely on the very basic principles of flight that the Wright brothers established over 100 years ago. This is the Hindenburg airship moments after it caught fire. It is a significant moment in the history of flight, as many believe that this fiery accident meant the death knell of the commercial airship. The Hindenburg was a German Zeppelin that was destroyed by fire while landing at Lakehurst Naval Air Station in New Jersey on May the 6th, 1937. 36 people, or about 1/3 of the people on board, perished in the fireball. Airships took to the skies around 1900. Von Zeppelin is regarded as the father of the airship, and by the outbreak of World War I, his Zeppelins could achieve 136 miles per hour, reach a height of 4,250 metres, and carry 2,000 kilograms of payload. Very quickly, the military saw merit in the Zeppelin. It was the first viable method of navies to view beyond the horizon. The naval fleet that had the advantage of peering over the horizon could evaluate an opponent's strength and manoeuvre itself into the most favourable position before the battle began. The United States Navy was also inspired and went on to build the Shenandoah, Akron, and the Macon. The Akron and the Macon were outstanding examples of airship technology. They were nearly 800 feet long and capable of 75 miles per hour. These airships were not only used as reconnaissance platforms, they could also carry and launch aircraft. They could carry 5 Curtiss fighter planes, and they could launch and retrieve in mid-air using a trapeze apparatus that was lowered through the airship's hull. They had a load-carrying capability of approximately 160,000 pounds, and this was more than ample to carry the little fighters. Thousands of successful flights were conducted by both these mammoth aircraft. Although the Germans, British and other countries used airships in various manners, it was the Macon and the Akron that are probably regarded as the pinnacle of the airship's reign. Airships served the Navy well, but their time was running out as advancements in aircraft were gathering pace. Unfortunately, many regard the airship as ineffective. Perhaps newspaper images depicting wrecks and fireballs, such as these of the Shenandoah, fueled such skepticism. But navies use these lighter-than-air giants with a reasonable degree of success. However, the moment planes became reliable, the airship's day as a military instrument was numbered, as they were easy targets for the smaller, faster and more manoeuvrable aircraft. As transatlantic ferries, airships such as the Hindenburg were a very real competitor to the ocean liner. Airships were much faster than ships. However, the Hindenburg disaster received much media attention, and as air travel was in its infancy, the horrific images burned negativity into many people's minds. Unfortunately, the Hindenburg disaster may have never needed to occur, and airships may have had a longer commercial lifespan. If, like modern airships, it had used helium as its lighter-than-air gas instead of hydrogen. The Hindenburg was originally intended to be filled with non-flammable helium, but a United States military embargo on helium led the Germans to modify the design of the ship to use highly flammable hydrogen as the lift gas. The Germans had experience with hydrogen, and no hydrogen-related fire incidents had occurred on civil Zeppelins, so this switch from helium did not cause alarm. Such was their confidence in their ability to handle hydrogen that a smoking room was present on the Hindenburg. It was pressurized to keep hydrogen out. This is the Deutsche Zeppelin Reederei GmbH and was developed by a descendant of the original Zeppelin company, which built the Hindenburg. The limited run of Berlin flights start at Tempelhof Airport, itself a masterwork of the Third Reich architecture, dating back to the old Zeppelin's heyday. Only 12 passengers fit in the new Zeppelin, a fraction of the number that could ride the original. Surprisingly, many of today's passengers were old enough to remember the glamour of the old Zeppelin and are fulfilling long-held dreams to ride in one. It has never been conclusively proven as to why the Hindenburg suddenly burst into flames. Many theories have been put forward. The Hindenburg is still the largest aircraft ever built. It was longer than 3 Boeing 747s placed end-to-end. It had cabins for 50 passengers and a crew of 61. The demise of this mammoth was also the demise of the airship as a commercial aircraft, and it is doubtful that we will ever see airships again ruling the skies as they once did.